Welcome for those that are joining us. Today, like I said, we're going to learn about the word and programming. We're going to hopefully demystify how difficult it can be. I am out in my garage today. It is a hot day. It's a nice, bright, sunshiny day. Just give a little bit of a tour about what's outside there. Nice, bright day. So we're going to work on using a ZZero plate to be able to check and verify what the material thickness is by using the ZZero plate to go on the top side of it. Then we'll move the material out of the way and also touch off of the plate again at a different level. We're going to do a little bit of math within a Shopbot part file that's going to then give us that difference. But before we get into that, and to help make everything a little bit easier, we're going to talk about Shopbot 3 and two-letter commands and what it's all about. Most of you probably already know this, but we're going to go through it again just to see what it is. So if I want to home the machine, it's a C3 under the cuts menu. So I'm just going to home that, which is the same as clicking the red button on the red position screen. And through this homing process, we see this input switch number 3 lighting up. That's a trigger saying that that is on that switch, and we're able to react on that switch. So the next thing we're going to take a look at is how to move the machine around just by using the console. There's two types of movements we could make, are move commands and jog commands. And they're also in the menu item. We have moves and jogs. But I'm not going to use the mouse to be entering anything in. I'm just using the keyboard. And we are at the location of 00. And if I want to move the x-axis to the location of 6, I would just type in M6, 6, or MX, and then comma 6. And when I hit enter, it's going to go to that location of 6. I want to mention that we're always giving it a location to move to and not a distance to move. So if I ask it to move once more, MX6, and enter, it's not going to go anywhere because we are already at the location of 6. Now I'm going to move the Y out also to 6. So I'm just going to type in MY6 and then enter. And the Y axis is going to move out to the location of 6. So again, it is to the location and not to a distance. The next thing I'm going to kind of take a look at, and again, what we're going to be doing today is a more advanced feature and is really not needed to do basic operations. This is just kind of fun, advanced stuff and stuff that you're able to make the machine do that you may not be aware of. So that is basic movement commands. We also have a command that is called or zeroing commands. So bringing down the zero menu, I'm just going to type the letter Z. That's the first letter. The second letter in any command is listed in brackets. So if I want to zero the X, I could simply type in X, ZX, and that sets the value of X to 0. So if we see in the red position screen, it now is reporting the X to be at 0. So the next thing we're going to take a look at is if we, rather than setting a current location to 0, I want to set a current location to a specified value. So if I know that I am sitting at the value of X is really 6 inches, not 0, I could go into values and then access location values. So that's VA, and bring up a little fill-in sheet. And I'm just going to type in 6 for the new location of X and select enter. And again, nothing moved. But notice in the red position screen, X is now back in reading 6 inches. that it is now reporting that it is 6 inches from 0. So with that done, there's one more item that we want to look at and understand, and this is called system variables. System variables are ways that we're able to incorporate different values or get different values out of the Shopbot software. So the one that we're really going to focus on today is getting the value of what is in that red position screen. We could kind of test some of these values out by going to the utilities menu and opening up the calculator. So if I want to see what the position of Y is, I could enter in a % sign that is indicating that it is going to be a system variable. And in parentheses, I'm going to put 3. So that is the system variable for the value of Z. When I hit calculate, it gives me just exactly that value. We could see the whole list of system variables in our help folder under help, and then we should have a here for programming and developer resources. I'm actually going to back up one because it may actually be under the help menu or help folder of the Shopbot. And then we have the Shopbot system variables. So it's a PDF file that lists all of the variables that we're able to access. So if we see here, position of Z is number 3. If I want to get the status of, say, a switch, input number 1 is 51. So let's just take a look at what that does. So going back into the control software on that calculator, I'm going to type in 51 and select calculate, and it gives us a value of 0. And notice that over here, that input number 1 is not lit up. So at this point, I'm just going to take the alligator clip and clip it onto the plate, and that closes the circuit to input number 1. So now when we click calculate, the result is now 1. So rather than it being 1 is on, 0 is off, we're able to use that within the files that we have. So I'm going to uncheck or clip that to make sure it's off, click calculate once more, it's there. So the reason I'm pointing this out, we're going to use all of these numbers. So let's just say we want to move the x-axis out to 6, if we wanted to move it another 3 inches. I mean, I could do the math fairly easily. 6 plus 3, I'm going to give it a value of 9. So mx9 would move out there. But if I didn't want to do that math, we could do that math right within here. So I'm going to do a %1, which is going to be the value of 6 plus 3. And when I hit enter, it's going to go out and move to 9 inches. So hopefully that is all fairly easily to understand. And we're going to take now a little bit of a look at some programming and what has happened there. So we're going to first go in and create a new file. And we're going to use some other programming statements here. And this is how the ZZero plate functions and works. I'm going to open up just a new editor. Just Notepad works just the same way. This is just a text file that we're going to use to create this. The one difference is the editor, it does give us some color coding to indicate certain commands are entered in. So the first thing that we're going to see how this works is just going to do basic math right here. So I'm just going to enter in that same command that I entered in the console, only I'm going to type it in here. So move x %1 plus 2. I'm going to save this file. And I'm going to select SB cut, which is sending that file over to the Shopbot control software, opens it up, and it's going to run. So we run that just as any other file. We can see it went from the value of 9, and it moved 2 inches because we were moving it from its current location out to 2 inches. So now we're going to get into more of programming, and I hate to throw out the first programming statement off the bat because it's a little harder to understand maybe, but it is what is called an on input statement. So on our line here, what this is saying is we are going from on input 1. So when switch number 1 turns on, we're going to go to contact 1. So to explain what contact 1 is, that's a label within the file. So let me really undo that file and explain what a label is. A label is a made-up word, whatever word you want it to be, followed by a colon. And I'm going to enter in another one, made up 2. So I have 2 made up words here. They are ignored by the Shopbot control software. They're just simply a way to jump to a current line. So I'm going to put this mx command inside of that one. And this one, I'm going to enter in an my. So I'm going to move the y, and then also going to change the system variable to 2, which is the value of y. So if we run this right now, it is going to move the x 2 inches from its current location. Then it'll move y 2 inches in its current location and stop. Nothing fancy about it. It is ignoring and not seeing either of these two. What we could do at the beginning of this file and an end statement. So let me just type the word end right here. So now it is not going to continue on in the file. It's going to end at that line right there and not run the my command. So just to test that, save. And we see it only moved the x and not the y. Going to do the same thing, put an end statement at the bottom. We'll save. Again, nothing has changed. We're just moving the x only. At the top of here, if I wanted to move the y and not the x, I could tell it to go to our made up label. And I'm just going to simply do that by typing in go2 made up 2. So what is going to happen here, it's going to skip past our made up here. It's not going to run and move the x at all. It's going to come right straight down to the made up 2. And again, I'll run that and we'll see that only the y is going to move. So hopefully that explains what a label is. And labels are used quite often to be able to jump around in code in different locations. So I'm going to introduce our on input statement again, bringing that in. So what this is saying is on input 1, 1, go sub. Go sub is similar to a go to, and I'm going to try my best to explain what's going to happen with that. So a on input 1, 1. So what it's looking for is input switch number 1 to turn on or become 1. That %51 that we looked at, we saw it as a 0 or a 1. We are able to react on that now. So if number 1 turns on through any of our movement, go to one of these values here. So let's, I'm going to bring the ZZero plate over to where I could just automatically touch that and trigger it manually, not by the bit, because at this point I'm going to say MX, comma 6. So the on input is only setting us up for this motion. And I am going to replace our contact 1 for made up 2. So what's going to happen here is the X is going to start moving to the location of 6 inches unless input number 1 comes on in the middle of that move. If it does, it's going to come down and move to the Y. So let's just see what happens. I'm going to change that and just move it back to 0 to give us some bigger motion. And going to come over here, and I'm going to simply just trigger the input by using the keypad. So we can see that the X is sitting 15 inches. We're going to direct it to move to 0. But if I hit the input switch, the X is going to stop moving and the Y is going to move from its current location to 2 inches, which is going to be the value of 12. That was a lot of words. So test, enter. As the X moves, I'm going to trigger number 1. We can see X stopped and then the Y made its motion. So hopefully that helped clear out and understand what the on input is doing. And now we're going to see the magic behind our ZZero plate and what our ZZero routine is really doing here. So I'm going to rename my contact, or my made up 2 to contact 1. Going to change the X value to move the Z, and I'm going to move the Z to a minus 200. Yes, I'm working in inches, and yes, I do not have 200 inches of movement on that Z, but I'm going to hope that it hits this plate and that on input switch works. And we're going to see that. So on input contact 1, I'm going to rename our contacts here and just delete that line, clean it up a little bit, and delete this. So just as we saw with that MX, is going to move the Z down until input number 1 is triggered. When it is triggered, it's going to stop its motion and jump down to our contact 1. Now, the one difference that I have here is this go sub command. So go sub means that it's going to go to our subroutine, which is contact 1. So since we're using a go sub, we need a return to return it back up. So I'm going to type in return. And on top here, I'm going to type the word end just to make sure that it doesn't flow down into our subroutines. So running this routine will hopefully just bring the Z down, touch the plate, and do nothing more. So I'm going to open up the keypad and move the Z in a little bit closer so our camera is able to pick up on that. There. So at this point, I'm going to run this file. And that's it. So it moved down, and right now it is touching, just touching the top of that plate. We didn't do anything with it yet. We haven't done anything other than brought it down to that location. So coming back to the file, I want to react on it. So I want to record the value of where it is. We know that to be percent number 3. And to be able to record that, I need another made-up word. And this made-up word is classified as a variable. The variables all start with a ampersand. It's a little and symbol above the 7. And I am going to label that Z1. I'm going to tell it that it equals 0. Not doing anything by itself other than it says that Z2 is equal or is going to have the value of 0. coming down into our contact 1, I wanted to say, now say Z2 variable is going to be equal to percent in parentheses 3. And click Save. So there is one more programming statement that I'm going to introduce here, and this is a message box. A message box is what pops up with a yes, no, okay, cancel with a message inside of it. So a message box is MSG BOX. Then in parentheses, it's separated by commas. I'm going to just put Z value is, and I'm going to enter in percent, or I'm sorry, ampersand Z2, comma, you could look these up, but the type of message box I want is 0, which is going to be just a OK button. That's all it's going to do is give me an OK button. A 1 or a 2 might give you a OK cancel. 1 might give you a OK cancel and continue or something like that. So hopefully my audio is working. I am a little bit distant from my wireless connection. So hopefully my internet is functioning okay out here. So again, starting off, the first section of the message box is the body, the text within the main body. The second 0 is the type of input that I want. And the last section is going to be the title. And we'll see how all this works out. So I'm just going to say first. And I'm going to save this file. So it all works from top to bottom. So we'll just kind of glance through this at top to bottom and see what's going to happen here. So that's a variable, Z2, setting it to the value of 0. Going to set up for an on input switch, doing nothing by itself other than just getting it ready to go. We're going to move the Z down to a -2 inches. Then once the switch gets hit, if it gets hit, it's going to jump down to contact 1, give the Z2 variable a new value of its current location of Z. Then it's going to return back up to the next line after its motion and post this message. So let's see what happens with that. First thing I'm going to cancel is do a page up to move it back off of that plate. Run our test file. And there we go. So now it's giving us the value of the Z. Well, yes, I mean, we could just easily look over on that red position screen and see what's happened there. But this is just taking it in baby steps to see what's going to happen next and how we're able to use variables to record what is happening here. So I'll say OK to that, and the file just ends because we don't have anything else being done. I don't want it to stop directly on that plate. I do want to record its value when it hits that plate, but I want to move it up after we record this value. I do want to move the Z up. So to do that, I'm going to type in move Z, comma. I have no idea what location that is really going to be. So this is the reason that we need to know the system variables of its current location. So I am going to enter in %3, and I'm going to add 1 inch to it. So I'm going to bring it up 1 inch above the plate. And come back up to the top. So one more thing I'm going to do is add another statement to this. We're going to touch off again, but let's just take it in small steps. I'm going to save that file and go and run it again. And I'm going to open up the keypad to move up off of the switch. So we still have the value, and it still recorded the value of the location of where the Z touched that plate, which was 10.474, but we also moved up of an inch from there, which is now 11.474. So we're going to add another switch contact or another variable. So just to make life easy, we're going to use Control-C and Control-V and relabel that contact 1 to a contact 2. And on top here, I'm going to do a Control-C, Control-V to give us another variable of a Z3. And change this down here. So again, that Z3, they're made up words. They could be whatever you want them to be. Good programming practice would be give them a logical name. So Z2, Z3, it's really not a good logical name. It really might be touch 1, Z touch 1, Z touch 2. At least that is indicating something a little bit more about what that variable is for. So again, just do a Control-C, Control-V, and just basically do the same thing. So it is going to set up the on input, contact 1, move the Z to -200. When switch number 1 gets triggered, it's going to jump down to contact 1. After it does the section of code that is here, it's going to return back up to our location after that move, set up another on input statement and go to contact not 1, we want it to go to 2 because we want to record the next value of the Z. Move the Z down and continue on. So let's see what happens when we run this file. So again, the value of Z is just reporting the first contact that we had in contact 1, which is reporting that Z2. We're almost complete with our programming. We've collected the data that we need. We just now need to know what to do with it and how to react based on it. So one thing that we could do is I'm just going to enter in another programming statement, and that is the word pause. Typing the word pause is only going to pause the machine at its and post a message saying it to continue. And if I put a statement or a comment above that pause, let's see, move plate. And this time I'm going to change the value of this message box or that variable to be Z3, which is down here. So at this point, again, I will say save. I've not done anything except for added that pause. That's the only thing I did other than change the variable name down here to report and give us the value of another variable. So we're going to follow along and see what happens here. There is the message that I'm getting because we are sitting on line number 9. We can see that word pause, and it's saying move plate. I'm just going to hold my hand underneath of it up a little bit and hit OK. And it is done. So now we can see it. We have another variable or another value of that, which is the 10.86. So that would be a way to record both the different heights. So let's see what happens or how close this might measure to the top of a piece of MDF. I'm just going to move that MDF over on top and say OK to this message. I'm going to run this file just the same and click Cut Part. Run the test file. asking me to move the plate. So I'm basically just moving it off the material, moving the material out of the way, bringing that down, and we'll say okay again. So we have values in recording. We're able to see those values are different. But now what we want to do is just a little bit of math and add another variable. So I'm going to say okay to this. Come back to our file. This time I'm going to be a little bit more logical with my variable name. So I'm just going to say MER material thickness. I'm going to start off by setting it to 0. It's kind of initializing a variable. It's always good to have variables, all variables used like at the top of the file, initializing them, making sure that they have a value and they're there. So that's the reason why I do that. It's not required. You don't have to, but it's good practice to. And just keeping everything kind of in line. So now I'm going to take this variable, just do a Control-C to make sure that I have the spelling correct, and a Control-V. So now I'm going to say that variable is equal to Z3 minus Z2, change the value in our message box to the material thickness, just changing the wording here a little bit. Click Save, coming back to Shopbot 3, running the file. Move the plate, put it on top of material, and select OK. So it's telling us that our material thickness is 0.778. Now, that may or may not be the actual material thickness. If you notice, my table surface is, the board is not laying real flat. I've got some divots on the table from where I've had things screwed down. So really what it is giving me is the difference of different locations from the first touch to the second touch. So now that we have somewhat of a working file, we want to just clean it up maybe a little bit to make it more readable and understandable. I've already done so, just not even thinking I was doing it, just out of being used to it. I've indented some things, so it's very clearly able to see that contact 1, we have a grouping here and another grouping of code here. I want to do the same thing up above. So I might do the on input, indent just a little bit, and also indent all of the items. So just to make it a little bit breaking up so we're able to understand and just kind of get an overview of what is happening here in different sections of the code. So what is, right now we're moving it to 1 inch above, moving it back up to 1 inch. Let's say if we did this and I wanted to measure, you know, thicker material that was thicker than that 1 inch, and just trying to see what I have that I can lay on top of. You know, if I wanted to measure what the total thickness of this height might be, and you see it's not there. So we might need to put a way to move the machine from within the code. So rather than simply having this pause message, I might choose to open up the keypad. If you are familiar with the command to open up the keypad, a lot of you might click this red or yellow button in the red position screen to open it up. You could also type K or type SK to set keyboard. So knowing that 2-letter command to open up the keypad, we could also use that command within our cutting file. So after the pause, I'm going to type in SK, and before the pause, we'll say we'll click save on that and see what happens when we run this file now. So there is our message with the pause on line number 9. When we say OK, the keypad opens up to allow me to move the Z up out of the way. Again, relocating the Z in material. When I close the keypad, right now it's kind of paused on line number 10 with that keypad there. When I close the keypad by clicking the X or escape, it's going to continue on with the rest of the code. And give me the total value or the total distance from the top of the trigger here to my table surface is just a little over 2 inches. So hopefully I kind of explained that. Hopefully you guys enjoyed some of this more advanced stuff. I'm not sure if anybody will really use a lot of it, but it is a way to have things work in flow. So you're able to use programming to set up loops to where it could do things over and over and over again in different ways. So if you had a file that ran multiple times, you could set it up to do just that, to set this loop up and use the go-to statement to run it multiple times. So hopefully that's an explanation. And well, finished a little early. Got 20 minutes into our left in an hour. Anybody have any questions? It might be even worth to hear if anybody's still out there listening to me. Yeah, so an example of why you might use a file within just Shopbot. So say if you wanted to have, say if you did design something in Shopbot or in vCarve Pro, and you want it to be able to cut over, one over and over and over again. So let me see if I can't quickly get myself in trouble with this. So first thing we'll do is create a file in vCarve Pro, or I'm using Aspire, but it really is the same as what we're using it now. So let's just draw out a circle, and I'm going to put it just at 0, 0 to make things a little bit easier for this example. So about a 1-inch circle, going to create a toolpath for it. Edit some of this and make it just a single pass. Close that, and I'm just creating a basic file. It could be whatever you want it to be. So I'm going to give it a save toolpaths, and I'm going to save it in the SB parts folder. You don't have to, but I'm just doing that just to keep it somewhat organized. So we now have a file that cuts the circle at the specified location of 0. So to run this, I'm going to just do a Z2 at this location, ZZ as well, and we could run that file. And we see it just cut that one circle at its location. Now we're going to take a little bit of a look at the fill-in sheet, just to better understand it. You see it cut at 0, 0. So I'm going to move the X over 6 inches. And this time I'm going to file apart, run this file. Only this time I'm going to change this offset value right here and say that it's a 2D offset. So if you notice that it is sitting out at 6 and 6, it cut at that location. So what that 2D offset did was said that that is where we want to have our temporary 0 relocated. And I'm going to take a look at what it produced here. So it's an FP command, the file, 1, 1. So we see this 2 right here. That is the 2, the offset right there. So I'm just going to count 1, 2, 3, 4, 5 commas after the file name. So going to our test file, and I'm going to type in file part, comma, and I'm going to save this in the same SB parts folder. So again, running this file, this test file that is located in the SB part is not doing anything differently than just running that file alone. But what if we did this? Ran it once and ran it again, only this time I'm going to put 1, 2, 3, 4, 5 commas and put a 2. Let's do the same thing on top. So let's do there. So let's see what is going to happen when we run this. I'm going to open up the keypad. Move it down where we could maybe see it a little bit more. I'm not going to zero any XY or any of that out. Just going to run it right where it is, which is on the SB parts. So it basically cut 2 circles directly on top of one another. And it didn't worry too much about where it was that I had initially set the location of 0, because you notice it's out in -2 inches. So if I want to cut a series of holes that are 1 inch apart, in between each call to this file, I could type in mx, comma 3. We'll save that, run this file again. So you can see that just by creating just that one circle in vCarve Pro, we really cut 2 circles that are 3 inches apart from one another. Getting more advanced with this, and this is what we're talking about with loops and such, we're able to set a loop to where we could only have one file called, and it could just run that over and over and over again, to where we could even have it like post an input box that asks us, how many circles do we want? We could say 4 and have it automatically cut that same file 4 times at 4 different locations. So hopefully that kind of maybe gives you one example of why you might use some of this programming versus vCarves Pro, or use a combination of both, but it's definitely a little bit more advanced doing this programming than just coming straight out of vCarves Pro. All right, well, we're going to call it a day for today. We'll be at it again next week. We got Tuesday and Thursday that we will have some sort of a project type class session. Tuesday, we're going to look at importing files from other software, how to manipulate that around, challenges that might be in there, and just how to handle different things. Might even take a look at why we might want to use inlays in some examples with maybe a textured background and such. Thursday, not quite certain yet. And then we have a beginner's class next Wednesday. It'd be a chance for anybody to ask very basic questions and get the basics figured out if you need that type of help. So thank you again for joining us, and we'll see you again next week.